Earlier, we stated that for all normal probability curves, the area within one standard deviation of the mean will equal 0.68. That means the area beneath the curve be centered at the median, or sorry, the mean, plus one standard deviation above or one standard deviation below. That area will be 0.68. What is the probability of values falling outside this interval? This is the question we will investigate now. I think a few pages back, I kind of gave it away. I'm sorry about that. We started talking about it. We will start with an example about normal probability curves in general. Then we will provide some specific examples. In this example, probability X is more than one standard deviation above the mean. Okay, I think we kind of talked about this before. We just said basically this is what we're looking at. Okay, I'm going to cut it off here. This is mu, the mean is in the middle. Mu plus sigma, or the mean plus the standard deviation, is the cutoff point here. Mu minus sigma is the cutoff point here. This area we know is 0.68. But we know on the other hand, I guess, we know that the area beneath the curve total is 1. So the red area, this plus this, that plus the blue area in the middle must be 1. So 1 is equal to the red area, plus the blue. But that means that the red area, if I'm not sure what it is, should be 1 minus 0.68, which is 0.32. That means that those two red areas, the left and the right, total together is 0.32. Okay, but this is supposed to be symmetric, so the left red area should be equal to the right red area. This is two red areas put together. If I want just one red areas, I would say that's half of the total, because 0.32 would be the left and the right put together. Half of 0.32 is 0.16. So this area, the left red area, 0.16, the right red area should also be 0.16. Okay, that's kind of the idea. The area under the probability curve is always 1. Okay, we got that. Okay, this is just telling us what we just kind of calculated. Okay. I'm gonna move down so we can see the next example. Sorry if that went fast. Just if you want, you can always rewind and see it again. All right, let's see. Probability with birth weight is less than 100 ounces. Okay. Birth weights have a normal probability distribution with a mean of 120 ounces and a standard deviation of 20 ounces. What is the probability that a randomly selected infant weighs less than 100 ounces? The answer is 16. And that's because less than 100 ounces, that happens to be mu, the mean, minus sigma. So it's exactly at that cutoff point in the curve above where we saw it's like the left red area. So they're asking what's the area under this curve? That's exactly what we just calculated. If they had said, what's the probability that a randomly selected infant weighs less than something other than 100, like 90 or 80, we wouldn't really know. We have to use other means to figure it out. But the value they asked happened to be mu minus sigma. Yeah, here's how we reason through this using the normal probability curve. Yeah, we just kind of talked about that. Okay, let's move down now to the next example. Now they ask, what's the probability that the birth weight is more than 100 ounces? Well, birth weights have a normal probability distribution with a mean of 120 ounces and a standard deviation of 20 ounces, because it's the same example as above. What is the probability that a randomly selected infant weighs more than 100 ounces? So on this curve here, on this chart, you can see that 100 ounces is here. If they want to know what's the probability that an infant randomly selected has a birth weight of more than, that would be everything larger than 100. That would be this area in the middle plus the larger area. So really, you could just add the areas. The probability of X being greater than 100 would be the red area's probability, which is, they have it inside there, 0.68, plus the probability on the right, 0.16. And that's it. Yeah, so 0.84, is that right? So 84%, you have an 84% chance that your randomly selected baby will have a birth weight more than 100 ounces, I guess, yeah. That's just only because we're interested in these certain values that are right at the cutoff point, that there's inflection points. That's why if they mentioned any other value like, yeah, 80 or 160, then we'd have to use other means. But if we know the standard deviation and the mean, we can calculate probabilities at mu minus sigma and mu plus sigma. Mean minus standard deviation or mean plus standard deviation.